Alright, time for another DreftPhysics.com, debatephysics.com also, video presentation. So, this is an Eric Weinstein video, and he's an interesting character. I mean, seems to have some knowledge of every subject imaginable. Kind of a deep knowledge of some of it. I don't know how he absorbs so much information, but he certainly has an awful lot of it. But he's also, like all the other characters, just nutty stuff. This whole unification of physics, or the fact that physics needs to be fixed, by his perspective, to some extent, looking for something better. And for the purpose, because we need to shoot humans off the earth. I mean, just wacky crap where, what the hell are you talking about? I mean, humans have gotten more and more entertained by, of this electronic medium. I mean, they're almost suitable for test tubes now. Why would you bother launching them anywhere? Just, put them in a vessel and plug them in, and they won't know the difference. But anyway, it's just kind of funny. But why bother? Because none of them are doing anything. It's just not. It's not worth the double A battery to run them. I mean, frankly. But anyway, so he has a theory, and I've heard of it, but I haven't really been able to figure out what the hell it is. So it's some kind of thing called geometric unity. I don't know what the hell that. It's just, fuck you, YouTube. It's just so obnoxious. I mean, everything's added now. There's ads everywhere, even for climate change. Anyway, so I'll play some of it from here, I guess. I mean, I want to get to. So he did an actual physics lecture, I guess, introducing his theory to an audience of physicists, something like that, anyway. So hopefully we'll get to that. So apparently he's trying to describe how this theory works, and I couldn't even really understand his description. But anyway, he's done. He says here, I'm doing away with space, time, and replacing it with. Why would you replace it? Space is an empty nothing, and time is just a function. So there's nothing to replace.
With what I've termed an observerse.
An observer. So yeah. So people have made fun of me just saying a bit of force, like that's too funny an idea. He's calling it an optiverse. Oh dear.
Now, an observerse is an unusual gadget in that it's thought of as two separate places where physics takes place, connected by a map. That means.
So now we're doing some sort of multi-dimensional thing, and apparently this is where the dark matter is hidden, is in the other optiverse.
Effectively, that we are in something like a stadium where there are stands and there is a pitch. And the playing field that we think we see may not in fact be where most of the action is taking place. In fact, not all of the fields live on the same space. So.
Oh, brother. So this is going all bad already, right? I mean, not all the fields are in the same place. So he's describing some kind of like 10-level chess or something. And that's the elemental, simpler, better theory. Yeah, I don't think so.
When we see waves and particles dancing around, they may have separate origins in each of the two components of the observerse.
So the things are not only, they somehow they have not only superposition in that you can pile them all into one place, but they are doing the same thing where somehow they can be in more than one place at the same time.
What I hope to do after this is to gracefully and gradually develop the theory under my leadership. Now, why do I say
he's going to lead his own band. I have my own little army that I'm going to lead. The army has me in it, and I'm in it, and also myself is sometimes in it. And yes, we're all in agreement that I should be president. Yeah, I've often said the same thing. Yes, I'm president of my own club too.
that? There is a belief in physics and in most fields that the field should behave in a communal fashion.
Oh, the field could be communal. I mean, it's just so, the field. All of this talk is like, there's a separate field for 400 different particles as current physics describes it. So, but again, why? I'm just saying it all moves the same speed. It does one kind of thing. It hits stuff and causes effects. I guess I just don't know why you would keep making fields into something complicated when they're obviously the transmission medium. They're not complicated.
And that people should put forward their ideas and other people should joyously build upon them, and that the
Joyously joy. It's all joyously joy. No, that's not. I don't even know what to say to that kind of stuff. Collaborate with me as long as you say I am Lord. Well, no, I don't want to do that. I don't like your religion.
community should be allowed to name the various accomplishments for whoever they say accomplished those things. There's not a way. There's not a way in hell that I'm letting that happen. My experience with this community is that it simply can't be trusted to behave equitably, given the fact that it is so resource-starved and constrained. People simply do not have the freedom to be generous, kind, and accurate as to who did what. Furthermore,
Brother. So again, who cares if you're in it for the science? You really don't care about all this credit crap. So it would be nice just to see something produced. Whether, it's always nice for somebody to get rewarded for their efforts, but that's also something you can do now quite easily. Some people on the internet don't need to, have commercials in their video because, frankly, they have such large audiences. If they just say, please donate, they'll probably get enough money to live on. But that's not what they want. They want a lot more than that. All right, we jump ahead a little bit.
told could never work. Why is the leading physicist in the world placing them on the board and saying that these are the equations from which all of something called Donaldson theory can be derived?
So you see, this is the kind of stuff where you just say, what is a Donaldson theory? How could he know about all of these obscure references? It seems just amazing that somebody would have time to collect all of these references.
What I'm giving you, at least at a minimum, had the ability years earlier to provide those equations from a different source. There's something called Seiberg-Witten theory, which I have no claim on. But the actual equations that are called the Seiberg-Witten equations came originally as an outgrowth from investigation.
All right, so that's pretty scary. That this whole theory thing is going to be a bunch of silly fucking equations. Like, we've already been there and done that. Couldn't we actually see somebody draw a picture of how the world works?
Of this theory. So at a bare minimum, the Seiberg-Witten revolution should have happened at Harvard rather than Princeton. And it should have been recognized that this theory was capable of at least at a minimum giving birth to that as a side project. The other thing that I think is incredibly important.
Oh, Jesus. I need a break already. Jesus. This is going to be really, really bad, I think. All right, I'm back. All right, so I did make a couple of efforts to contact Eric in the past, and both of them failed, at least two efforts. I don't know how much I offered him, but, I tried to make it known that, it really would be in his interest to take an interest, and I just couldn't. You can't persuade any of these people. And that's, it's physics, so it's not very easy to do. You can't just say, I have a better explanation for the double slit experiment, and that's all you need to say. You have to say more. And the more you say, the more you need to say, just give everything context. But anyway, continuing.
Is that we've never seen how a universe that looks like ours could possibly emerge from almost no assumptions whatsoever.
Who cares? So that's one of these things where, you're trying to predict what happened 13 billion years ago, and There's just no traceable footprints. So it just seems like kind of silly speculation to say you're going to try to figure out how electrons poofed into existence. Good luck, but I don't see the point in it.
And I believe that even if this theory were to turn out to be wrong, which I don't think is likely.
Oh, brother. Sorry to laugh, but
I believe that it would give us something to go on. We would at least have a first candidate of how a hopeful theory of everything.
So that's all it's really about. So that's the catch word here, a hopeful theory of everything. So, it's really not about science. It's not about the facts. It's not about getting real. It's about finding hope.
Would look and how it would go wrong. So under any circumstance, I think that I'm going to be fine if the theory doesn't work out. I will have at least taken my shot on goal. And I think that that's probably more than almost anyone can ask from a life.
Whatever. It was a shot in the wrong direction, or you shot it into the crowd. Failure sucks. I mean, it just does. And so the fact that you'll be fine, well, that's good. But, it's not great being fine. It's not great having to live with your failures. Failure, period. So, yeah, it's hard to, I am equally confident that my shot isn't a failure. So I don't have much fear of failure because I know I didn't fail. It works too good.
To attempt to make contact with the deepest question that we've ever had.
It's besides the working part. It's just that the theory is really just what is the default when you get rid of the bullshit. So again, it's once you eliminate the lies and the nonsense and the crap, the truth just sits there and shines all on its own. You don't need to do anything. You almost don't need to look for it. It's just getting the shit off of it. Just rub the shit and the diamond is visible.
Which is, what is this place? And what brought it into being?
Well, that is just, again, I just don't know why anybody would even think about it. Like I said, I make jokes, but what does it matter whether a turtle farted it, or, a brontosaurus, or what? Who cares? It's not. It wasn't farted by a god. It's not some sort of designed machine. It's a mess. Something with intelligence does not create mass murder of children as a great evolutionary plan or blueprint. No, they don't do that. Duh.
Lastly, I want to just talk about a personal aspect of this, which is, what does it mean to come to an end? Whether or not this theory, in fact, does what I claim, I think
Come to an end? That seems kind of ominous.
it does. I don't know. But I do know that sooner or later, in the era of intercontinental land exploration, someone found the last landmass. And that must have been a very strange moment when there was nothing left to do. I think whether or not this theory, in fact, accomplishes that is one question. But we all have to...
Whatever. Obviously the what to do. Having the ability to even you invent the blue LED. Well, now you have lots of uses for the principle. The idea can be applied to maybe making an X-ray LED. You can take it to the next level, and then you can find all kinds of uses for the device you made. So there's lots of work to be done.
Plan for what it is that we think will happen when man at last learns his own source code.
Oh, brother. So this is all kind of talk. It's also this kind of wooey and mushy, like there's a source code somewhere. And no, there's evolution, and what we are is fish who have a very big ego, and think they're doing something really, really fancy when, even this conversation is just flipping fins. It's just a bunch of reflexes. The source code is I've been programmed to be an asshole, frankly, by cultural crap, and there's not much else there.
In fact, this was the last edge question that I answered for John Brockman, which is, does something unprecedented happen when man at last learns his own source code?
So whatever again that means, source code. I thought the idea was physics. I didn't think it was some sort of recognition of exactly how our brains are manipulated by hormones and electricity. But I mean, come on, what's the source code? It's a program. We're born an idiot. And we have to spend years, even decades, learning how to be a decent human. Even marginally. I mean, there's people driving up and down the street right now in this area, 40-year-old morons who haven't figured out they maybe shouldn't go 60 miles an hour down residential streets. Fuck. And you're talking about a source code? Eh.
I don't know the answer to this, but I want to return to the same spirit that I started this when I was 18 or 19, which is that of joyous investigation.
Oh, jeez, I just... Oof. Oof. So, obviously, it's not very joyous to recognize that people are talking shit, that highly intelligent people are propagandizing and shoving crap down people's throats. I don't know how you joyously have to do that job, so I'm not seeing anything joyful about it at all. It's quite dismal and depressing how much work you have to do to get people to recognize the simplest facts. So, yeah, I don't get it. Hope and joy seems to be the theme here. Ew.
Brave, open-hearted,
Open-hearted hope, joyness.
undertakings, and I also want to bring back a different style of scientific investigation. There has been far too much communalism.
Oh, communalism. So anyway, no, it's called confirmation bias and bandwagon riding. That's what there's been too much of. So because people aren't thinking enough independently and they're just being drones for a machine of physics, the axioms of physics must be believed. It's just a dogma. They're just marching Christian soldiers. They're not really humans even.
In fact, there is a belief that there are no lone researchers and that everything is produced by a community.
Again, there's absolutely zero evidence that that's how it works. So every bit of evidence indicates that it's these unique individuals, that these outsiders generally who do something. But 90% of those in the last 100 years haven't moved the ball forward. They moved the ball backward. So we've made heroes out of people who are not scoring goals. They're doing a lot of kicking, but it looks like a goal, but it didn't really go in the goal.
And pardon my French, but this is absolute horseshit. I've been so long alone with these principles, equations, and ideas that I don't even know what my adult life will look like once I disgorge them and I begin to talk about them with the community at large.
So that's interesting. So, I mean, I wish you would have those kind of conversations, but frankly, I don't see that in any of your discourse where you make clear, okay, that you're not on board with. He's definitely a dissident about a lot of what physics does. So that's definitely the role he plays, but it's not. I guess it's not hard enough. I mean, he's too easy on the pseudoscience, flat Earth, UFO lying bums, and he's too easy on the physicists.
To many theoretical physicists who've taken some interest in them, but I've never put out enough to absolutely ensure that people are seeing what it is that I'm seeing. So whether or not the April Fool's joke is on me, I cannot tell you, but I can promise you that I'm not trying to play one on you. What I hope to show you is a lecture that was the first of 3 versions of this lecture that were delivered in Oxford over the course of a week. And one of the things that has held me back is that I have
So he did 3 of them. I guess the same lecture, just different versions. I don't know. But we'll find out. Take a little break. Alright, back. So I have changed the volume setting a little. But we'll see if that's dangerous. Because there's, I've been not doing it the right way, and I should correct the way I'm doing it so the volume. So it's a direct feed from the video. It's not going through my mic, which is causing some degrade in the quality. So sorry if it's all wrong.
a great number of people who I have to thank for effectively being my underground railroad when my career got into serious trouble, who made sure that I always had an opportunity to fight another day. And some of the most important of those people, one of whom occurs on this video, is Marcus de Soto. And Marcus, I just wanted to say thank you for your bravery, your courage, your friendship, and your encouragement. I know I've been absolutely impossible to you. I've made you wait for this, and I just want to say how much I love you.
Yeah, but it's a little mushy. Yeah, so obviously nobody's giving me any goddamn breaks, so I got nobody to thank. A couple people I got to thank about infrastructure of building the theory, but no one to thank for the impossible task of getting a fair shot to oblige physicists to make a rational debunk of it. And I won't get that. I won't get what I'm affording you, which is I'll listen to your argument, but you're never going to listen to mine.
I also want to thank Isidore Singer for effectively saving me from not getting a PhD by, I think, putting pressure on the Harvard department, and for coming to my assistance and making sure that I got a postdoc at MIT despite not having any publications at all. I'd like to thank Raoul Bott, who's no longer with us, who I should have invited to my wedding. I was very angry at him, but I didn't realize that he was saving me in a very difficult situation against a department that probably just wanted.
Oh, brother, so all these little personal intrigue stories that for which we get no real information. Thank you for that.
To see me gone. I'd like to thank Peter Thiel, one of my closest friends who's like a brother to me, for allowing me these 7 years since this lecture to lick my wounds, to get strong, to have a 401k, to buy a house, and to begin coming back to regular society after a very difficult and strained career. I'd like to thank Adil Abdulali and my...
Yeah, you think yours was strained. Hilarious. Anyway, yeah. You almost don't want it, it's so comical. The advantage these people have had. And, but anyway.
Michael Grossberg, the 2 greatest best friends from college a guy could have. I'd like to thank my grandfather, Harry Rubin, who believed in things that couldn't possibly be true and made some of them happen.
Oh, brother. So he can't possibly be, but he did it anyway because he was a magician. Yay. Or, whatever, a shapeshifter. He was a medicine man.
I'd like to thank my parents, Karen.
Oh, brother. This is whatever this is, but it's just it just seems inappropriate. Physics, please.
And Les Weinstein for all the good things that they did. I'd like to thank my brother Brett Weinstein and his family, Heather and the kids, for sticking by me. And
how'd the kids do that exactly? Why, they just hold up a sponge finger and you're number 1. Yeah, you're number 1, Eric. You're number 1.
I'd like to thank my in-laws in Bombay, India. I hope you guys are well. And lastly, I would very much like to thank my wife and my 2 kids for putting up with a lot of lost weekends, a lot of lost vacations, and believing that just maybe there was something to this.
Oh, brother. I can't even remember why he's got any of this sort of fame thing. But anyway, I'm like I say, smart guy. There's just no doubt about it. Okay, pretty articulate, pretty good speaker, pretty good arguer, all of that crap. So I'm not saying he shouldn't be on TV, uh, but it's just this is just so.
And sticking by me all these years. So I hope everybody really enjoys this. It may not be comprehensible. And after this,
Yeah, so that's the whole problem. It may not be comprehensible. I mean, I just, damn. That's really a downer, not being comprehensible. That really is, it kind of just bums the whole movie if it's not comprehensible.
this video finishes, I'll do a short presentation of some of the constructions that took place. Not all of the equations and things, which I think some of them were sort of botched on the board because they became disoriented the night before.
Oh, who cares? The equations. I mean, that's going to, like I said, we'll have to see. If it's just going to be equations, then I won't bother.
And rearrange things in a way that probably wasn't optimal.
I mean, if you can't draw something that, the rabbit is over here and the grass is over here and the rabbit hops to the grass. If it can't turn it into something tangible, what's the point? I mean, something with actual things in it that we actually know do exist, like an atom or something.
But I'll attempt to clarify these things going forward and to begin to present the theory as I see whether or not I can bring myself to once again work on it somewhat close to full time as a 54-year-old father of two.
Whatever that's supposed to mean. I'm a 64-year-old father of, none. yeah. I'm just trying to, I helped a turtle hatch from its egg once, so I guess I can, technically, I don't know.
So sit back, relax, and coming up next is the first of my 3 lectures at Oxford University on geometric unity. Be well.
Are you struggling in calculus?
Oh, fuck.
Having a hard time understanding your professor?
All right, back. This is the introduction in Oxford, so there should be an introduction of some kind, I would imagine. So that might be more interesting than the lecture, frankly. So let's see. Let's listen to that.
Well, welcome to this special Simone lecture. My name is Marcus de Sotoy. I'm a professor of mathematics here and the Simone Professor for the Public Understanding of Science.
The Simone, whatever that is.
And Charles Simone prepared a manifesto when he endowed this chair to guide the holder of the professorship in their mission. And I'd like to read one part.
He's got to be quirky and bald. I just want quirky, bald people that don't wear a tie.
Part of that manifesto to you. It said, scientific speculation, when so labelled, and when the concept of speculation and its place in the scientific method has been made clear to the audience, can be very exciting. It is a very effective communication tool, and it is by no means discouraged. And it is in the spirit of this part of my mission as a Simone Professor.
Doesn't seem like much of a mission statement. What did he say? Boldly go. No, there was no boldly go or anything.
That I would like to introduce today's Simone special lecture. I first met Eric Weinstein when we were both postdocs at the Hebrew University just over 20 years ago, and I had the feeling then that he was working on something big. But it wasn't until 2 years ago that Eric met me in a bar in New York, and he began to explain the mathematics that he'd been working on in private.
It is really kind of discouraging that all this is about networking. You really have to know somebody, or you're out of the circle, and you'll have no... You'll be like me. You won't have a list of the friends who helped you, kind of thing, So, yeah, it does suck. I mean, they're just kind of proving this is not nepotism, but it's whatever, groupism.
For the last 20 years. As he took me through the equations he had been formulating, I began to see emerging before my eyes potential answers to many of the major problems in physics. It was an extremely exciting, daring proposal, and also mathematically so natural that it's
So he had this experience years and years ago, and now that's why this guy's going to get a chance to lecture at Cambridge. So it doesn't really. I if I could have drawn 2 + 2 + 3, okay, on the wall in the bar, then maybe I would be, living the charmed existence.
started to work its magic on me. Over the last 2 years, I have had the privilege of being taken through the twists and turns of Eric's ideas. After our postdocs in Israel, while I went the academic route,
So this is all just buddy crap, right? This has nothing to do with science and anything. It just has to do with who I went to a bar with or who I went to the same school with. Shit. Gee, it's right there in the open. This is the kind of thing Weinstein complains about, peer review and how it's, crap. And, what's this? This is even worse. This is worse than peer review. You must be one of us review.
getting my professorship here in Oxford, Eric went a more independent route, working in economics, government and finance. So he comes here today as something of an insider and an...
I guess he wasn't too good at some of that stuff, because he's talking about how he only got recently a 401k and he got a house and stuff. So I guess he wasn't too damn good at the finance shit.
outsider, a difficult place from which to propose bold ideas. But having spent time seeing how powerful these ideas appear to be, I felt that it was time that Eric shared his ideas more widely, as I believe his perspective could give the scientific community a new story to explain some of the big questions on the scientific...
Yeah, well, okay. It sounds kind of hypey. I don't think he's going to touch a big question. Nowhere near a big question. He's going to answer some little questions.
books. I'm therefore very happy to provide a platform here in Oxford for Eric to share his ideas on a new theory he calls geometric unity.
Annoying interruptions and such.
70 minutes, after which we will have a period to ask questions. Eric.
You're going to have to get used to
Puke.
asking questions.
So it's a great pleasure to be here in Oxford. For those of you who are not aware, it is possible that no other university in the world has kept so tightly and kept the faith for so long with Einstein's great vision of a final theory for physics as a theory of pure geometry, a sort of elegance and simplicity of the highest order. And the name...
So Oxford basically pissing on Newton. Yeah, right. Just like Eddington did. Okay, and that was, they really did make that part of the story, is that Eddington was basically a shyster, and he was kind of dishonest in getting the funding for his experiment because he was basically implying that they were going to prove Einstein wrong, not that they were going to prove Einstein right. And, it would just show British superiority and all that kind of crap, and,
Names that are associated with Oxford that weigh heavy on me are Attia, Penrose, Siegel, Woodhouse, Hitchin. It's a very long list of people who, even when fashion...
Sorry, not too many on the list that have much relevance to me in terms of being brilliant or adding great insight. It's all nonsense about crap for which they have no photograph, no real photograph.
Did not hold those ideas in favor. Always kept the faith that there was much to be learned from the geometric perspective on physics. Of course, unified field theory, in some sense, acquired a stigma with Einstein's failure to find it, in the sense that even someone like Einstein, being tempted by the siren song of geometry, might lose their footing and go astray.
Now, so the simple truth is that all the forces are moving exactly the same speed. So why would you? And there is no strong force, but I just even if they knew the speed of the strong force, it would be the same speed, because the strong force really is a weak force. I mean, it's stick an electron between two protons and an obvious thing will happen. The protons will get really close to each other without any force, without any new force.
And in the years since, we've had a replacement.
This is the bullshit of physics, right? Because that just reminds me of the Kashmir effect they talk about, you know, where you just put two plates next to each other, and when they get very, very close, they snap into each other. And it's just because when they get very, very close, one of them has to go negative and one of them has to go positive. There's no other way for it to work. It has to happen. And that's what pushes them into each other. There's no force that does it beyond charge. And it's just a cascade. It's just like in a gravity well. If you throw stuff going both directions into a gravity well, so the two things are fighting each other, one of them has to win. And the resulting momentum will be the winner's momentum. How much more energy did the winners have?
Theory, which is that what is really calling our generations is the quest to quantize general relativity and gravity.
And you quantize it by just saying, well, you already know, Einstein already gave you a force that you could understand as being in quantum bits, and that was the photon. And yeah, depending on how you read Einstein, you're not going to get it, but I mean, if you make the bits, the frequency, the distance between them, clearly it's a quantized, clumpy force. And you can do the same thing for gravity. It works the same way. You're getting hit by a certain amount of clumps from space, and you're getting hit by a certain number of clumps that go through the Earth. And it just happens that there's less coming up than there's going down, and that's the differential you're in.
And I'd like to go back to the sort of earlier perspective that there's no evidence to date, in my mind, that we are being called to quantize general relativity directly. In fact, there's been more effort spent on that.
So again, general relativity isn't even there's no physical dimensions here. There's no physical functions. So how could you quantize something that doesn't have a physical connection to the rest of the universe, in the sense that you can't quantize gravity until you accept that gravity is force, and that the force has to be accounted like every other force. You have to conserve it in some kind of direct way, not in some indirect way. Well, it takes as much energy to leave as it takes to fall in. Well, that's not making it part of the universe.
Quest without very tangible results than Einstein spent as one man searching for years for unified field theory. So we have to, in some sense, begin to undo some of what we think we know in order to...
So I don't know if Einstein really was looking for a field theory, okay? Yeah, I think Einstein was looking for this pretty much clumpy particle theory.
truly reconsider and allow me to put some of these ideas before you today.
I mean, the field would be made of something, not nothing.
Marcus asked me to begin presenting these ideas here, and hopefully this is a first opportunity, but if the ideas are not good, then lighting on the aisles will lead you to safety, and your exits may be behind you. But in the event of a good flight, hopefully this will begin a conversation rather than end one. I feel in some sense that I'm presenting the works of another man, a younger man, someone who came of age right in the middle of the great string theory boom with the anomaly cancellation in 1984. And I look at this work and I see a young person struggling with the idea, why can't I see that string theory is going to answer all of these questions over the next 10 years, as we were told at the time.
So again, string theory is just more mushy stuff connected to some idea that there's vibrations, you know, good vibrate, you know, it's just, it's Beach Boy physics.
And making a very dangerous decision, which was, I think I'm not going to follow that particular path, and I'm going to follow another. And it's not clear where this path is going to lead us, but we're going to explore it today and see as best we can.
So I'll acknowledge that, you know, for me, it's, you know, when I was a kid, I totally rejected the diagram of a photon as this ziggly crap, and I saw it as stuff at a frequency, and that's how I said it's probably got to be. Now, I wasted a whole bunch of time trying to make their model fit, trying to figure out how I could make waves work, because they were so insistent I must believe in them because of the double slit experiment and other things. And that was a waste of time, because basically they don't have any evidence for this wavy crap, and there was no reason to believe it, and it should have always been understood that a photon is an event. It isn't a single little dot in space. It's a sequence of dots in space, and it's just a pattern. And you can break the pattern and remake the pattern. I didn't think of that, when I was 15. I'm just saying that my brain was already saying, it was already seeing gravity as rain. It was already seeing all of these functions as being swirls of stuff, not ether, not stuff that sticks to each other, not stuff that vibrates, but sand.
And so in some sense, I've been able to polish some of that young man's work, but I'm also struggling to reconstruct it, because as someone spending full time on that theory, he knew a lot of things that I no longer know. So, with that as a beginning, I'm just going to say one disclaimer, which is that this is not a usual talk. And whatever contract a speaker usually has with the audience, right now we're going to break that contract. This is a talk about ideas. And some of these ideas are bold. Some of them may offend some people because there's a sense that you don't have a right to be considering those ideas. But I go back to the admonition of Jim Watson that said, if you're going to try to make progress, big progress, you are by definition unqualified to be doing whatever it is that you're doing. So, in that spirit, let us begin.
I guess you're going to break some eggs. Yeah, you got to break some eggs to make a good omelette. Whatever. Yes, the resistance to the truth is a big problem, but I don't think he's going to be talking much truth.
What is physics to physicists today? How do they see it different from the way in which we might imagine the layperson sees physics? Ed Witten was asked this question in a...
So that's really the irritating part, right? Because they were so close, with Newton, Descartes, and Galileo, had gotten it so close to this idea of just understanding that there's this stuff called energy in the universe, and it just transfers from object to object to object. Things touch, poof. And, I impose some energy. Oh, poof, I impose some energy. I lost something, it gained something. And it's so close to the, and that's so... That symmetry, in my opinion, that's the beauty part, the part where they should be going, wow, this is so, it's so circular, it's so complete. Why would I stray from that, something that makes perfect sense? I could say that, oil is black, it's full of carbon, it was sunk into the ground. At the same time, the Earth seemed to get a bit colder. Well, that all makes sense, doesn't it? And we put the black stuff back into the cycle, back into the atmosphere, and it gets hotter. Well, that makes sense too, doesn't it? It really should be that simple.
Talk he gave on physics and geometry many years ago. And he pointed us to three fundamental insights, which were his big three insights in physics. And they correspond to the three great equations. So the first one is that somehow physics takes place in an arena. And that arena is a manifold X together with some...
Oh, okay, so this is really going to get so obtuse right from the start. A manifold. Dun-dun-dun-dun.
kind of semi-Riemannian metric structure. Something that allows us to take length and angle so that we can perform measurements at every point in this space-time
So we don't need any space-time, right? All we need is space. So that's what Newton was pretty emphatic about. So he began his book with the argument against relativity, which they don't really talk about, the bucket experiment, and a demonstration that it's just idiotic to think that we can't recognize when something is absolute motion. And you spin a bucket and it's clear the whole universe isn't spinning. The bucket's spinning, okay? And it's taking the water with it. And the fact is the water's being given motion to the water, and the water rises up the sides of the bucket. And there's no plausible way you could explain that as anything other than the bucket causing it and the universe didn't.
Or higher dimensional structure, leaving us a little bit of headroom. The equation most associated with this is the Einstein field equation.
Excuse me,
Probably should have had all that stuff drawn, as I was saying. Yeah, you probably should have had somebody else write this ahead of time, and then he wouldn't waste time writing it poorly.
And of course, I've run into the margin. So it says that
So again, the Einstein equation was basically written to explain Mercury's precession, and it's really probably just creating a fake oscillator, something to perpetrate, Mercury because it's close and it doesn't affect the other planets, and
piece of the Riemann curvature tensor, the Ricci tensor, minus an even smaller piece, the scalar curvature multiplied by the metric, is equal, or plus the cosmological constant, is equal to some amount of matter and energy, the stress energy tensor. So it's intrinsically a curvature equation. The second fundamental insight,
oh, brother.
I'm going to begin to start drawing pictures here as well.
Good, thank you.
So if this is the space-time manifold, the
Oh, brother.
arena, the second one concerns symmetry groups, which cannot necessarily be deduced from any structure inside of the arena. They are additional data that come to us out of the blue without explanation.
So they're not in the game, so it's magic. Okay, so magical stuff enters our universe and does magical things. Great theory.
And these symmetries form a non-abelian group, which is currently SU3 color cross SU2 weak isospin cross U1 weak hypercharge.
Yeah, so obviously there's just no point in me arguing any of that crap. The whole idea that all this stuff is, besides, having impossible relationships to each other, without any chaos or irregularities, the idea of an orbiting electron is just kind of silly. Orbits are really hard, not easy. And, but a spin too? Ridiculous.
Which breaks down to SU3 cross U1, where the broken...
And again, if you spin something charged, it doesn't change anything. So you can't, you spin a magnet fast enough, there's no poles anymore. You spin a blue light and a red light, it turns into a purple light.
U1 is the electromagnetic symmetry.
So whatever the electromagnetic symmetry is.
This equation is also a curvature equation, the corresponding equation. And it says that this time the curvature of an auxiliary structure known as a gauge potential, when differentiated in a particular way, is equal, again, to the amount of stuff in the system that is not directly involved in the left-hand side of the equation.
No, isn't this all so yeah, so fucking uninteresting. Oh, it's just so bad. So yeah, this isn't explaining an elemental universe. This is explaining battleships or something. This is something with way too many parts.
So it has many similarities to the above equation. Both involve curvature. One involves a projection or a series of projections. The other involves a differential operator.
Are there any electrons and protons in this model? Just curious.
The third point surrounds the matter in the system.
There we go. I was asking for it.
And here we have a Dirac equation, again coupled to a connection. But one of the great insights is that the reason for the lightness of matter in the natural mass scale of physics has to do with the fact that this psi really should have two components, and the differential operator should map to one component on the other side of the equation, but the mass operator should map to another. And so if one of the components...
We know that's not the problem. We know the problem is that you measure the weight of the electron by using mv squared, which meant you completely exaggerated the velocities portion of its momentum and therefore gave it no mass.
Components is missing. If the equation is intrinsically lopsided, chiral, asymmetric.
Chiral. I mean, you know. Can't you just say asymmetric? You have to say chiral.
Then the mass term and the differential term have difficulty interacting, which is sort of overcompensating for the mass scale of the universe. So you get to a point where you actually have to define a massless equation. But then just like overshooting a putt, it's easier to knock it back by putting in a Higgs field in order to generate an as-if fundamental mass through the Yukawa couplings.
Oh, brother. So anyway, there's just nothing here, right? There's just nothing here. The Yukawa couplings. Well, he's going to draw a picture, so let's see if that's something. Let me just get the hell out of here. Hard to imagine how this is an improvement over the existing nonsense. It sounds almost like double nonsense.
Let me, for consistency. So matter is asymmetric and therefore light.
Hello, everyone.
Oh, dear.
Liberal billionaires who absolutely hate our country, and hate it they must. Because
Yeah. God. Oh, God, what a big giant hunk of turd. It's just, look, it's a race between, you know, it is a giant douche and a shit sandwich. So, yes, he's the giant douche, and yes, she is the shit sandwich. But fuck, the shit is worse. You know, a bottle of douche has got to be better than, you know, a clump of shit. So, you know, we've already seen him preposterously waste every bit of money ever donated to him. So what, you know, I mean, it's just, but I mean, he's, you know, I mean, it's just, his whole life is the definition of colossal failure. He inherited more money than he has now. In real dollars. I mean, he's lost money his whole life and gotten away with it. And it's just amazing. You know, he doesn't know anything about anything. And he's running for president of the United States. Just amazing. 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 All right, back to the other garbage.
And then interestingly, he went on to say one more thing. He said, of course, these three central observations must be supplemented with the idea that this all takes place treated in quantum mechanical fashion, or quantum field theoretic. So it's a bit of an aftermarket modification rather than, in his opinion at the time, one of the core insights. I actually think that that's, in some sense, about right. Now, one of my differences with the community, in some sense, is that I question whether the quantum isn't in good enough shape that we don't know whether we have a serious quantum mechanical problem or not. We know that we have a quantum mechanical problem, a quantum field theoretic problem, relative to the current formulations of these theories. But we know that in some other cases, the quantum becomes incredibly natural, sometimes sort of almost magically natural. And we don't know whether the true theories that we will need to be generalizing, in some sense.
So when they say the word quantum, you just don't know what they're talking about. Entangled bullshit, or, you know, what is it? Now, if they're talking about the idea of some sort of Planck clumpness to the universe, well, that makes sense.
Have beautiful quantum mechanical treatments, whereas the effective theories that we're dealing with now may not survive the quantization. So what I want to do is I want to imagine a different sort of incompatibility. So let's take our great three theories and just visually treat them as the vertices of a triangle.
No, brother. Ken Wheeler.
So I'm going to put general relativity in Einstein's formulation. And I'm going to put the, I probably won't write this again, Yang, Mills, Maxwell, Anderson, Higgs theory over here. And
I guess that's Maxwell, but modified into what? Who knows? Oh, can't touch anything. So annoying.
I'm going to write the Dirac theory.
Oh, brother! So these are the references. These are the points of axiomatic relevance. Yeah, sorry, not even close. What you should be writing down is, well, we have photons going the speed of light. Then we have magnets that don't have a source of energy, so they can't really be producing a field, so they must be just reflecting a field. Then you could just do a better form of this mush.
What I want to explore is the incompatibilities not at the quantum level, but the geometric input. All three of these are geometric theories. And the question is, what are the compatibilities or incompatibilities at the level of geometry before?
Well, look, there's no way to escape some geometry when you're talking about points in space. I mean, a line is a geometric function. So, it's almost superfluous to call it geometric. Obviously, it has to be geometric. So let's go to another drawing and see if there's anything in here.
Or modern gauge theory.
Fiber bundle.
Geometric unity is the search for some way to break down the walls between these four boxes. What's natural to one theory is unnatural to another. Semi-Riemannian geometry is dominated by these projection operators, as well as the ability to use the Levi-Civita connection. Now, some aspects of this are less explored. Torsion tensor.
Oh, okay, yeah, this is just so obtuse. Just no real point.
And sections of this bundle are either, depending upon how you want to think about it, the gauge group H, or C, a space of sigma fields. Look looks like the Clifford algebra.
So he's just, we'll call him Mr. Name Drop, because that's all this, I mean, name drop, name drop, name drop, name drop. I mean, everything is the Clifford, whatever he said. Who knows?
At the level of vector spaces.
So next time somebody says my drawings are bad, yeah, this is a pretty bad drawing of the universe. Just, let's see if he says something here.
What can we write down in terms of equations of motion? Let's start with Einstein's concept. If we do Sheab of the curvature tensor of a gauge potential hit with an operator defined by the epsilon sigma field plus the star operator acting on the augmented torsion of the pair. Add. And it's almost the same operators. And this is now not just a great guess, it's actually the information for the deformation theory of the linearized replacement of the Einstein field equations. So this is computing the Zariski tangent space just as...
No, the Zariski tangent space. Fuck. Anyway, yeah, it's just terrible.
So then the question is, how do you see...
So again, just the idea that the universe would be this complicated. You know, that the elemental universe has somehow got all these players and all this bullshit in it. And it does... Basically, it's a push universe, frankly. It's just force moving from one thing to another thing to another thing to another thing. It's just not that complicated. And yes, it happens on this tiny scale. The real universe is just electrons and protons floating around in the space, being pushed around by a force. And, you know, just crazy, all these nonsense additions of complexity when it looks all straight line, pretty direct. The rays from the sun hit the earth absorbs some of it, and then some of it spits back to the universe.
Considerations. So let's say from Chern-Weyl theory, you would have a very diffuse, very small term. And that term would be the term that was playing the role of the cosmological constant. So in a large universe, you'd have a curvature that was spread out, and things would be very light, and things would get very dark due to the absence of curvature linking the sectors. And that turns out to be exactly our complex. So in other words, just to recap, starting with nothing other than a 4-manifold, we built a bundle U. The bundle U had no metric, but it almost had a metric. It had a metric up to a connection. There was another bundle on top of that bundle called the chimeric bundle. The chimeric bundle had a
Z and an action of a group rho on Z standing in for any bundle associated to the principal bundle, which is generated as the unitary Riemann curvature. But if you think about what Einstein did, Einstein had to go further and reduce the Ricci curvature to the scalar curvature, go in the square part of the Dirac square. So two of these equations unify differently than two others, and the two pairs are unified in the content of a Dirac square.
Brother. Okay, so that's enough, right? Yes, I'm done. Fuck it. There's just no hope of turning this into something I can understand as having something to do with the universe I exist in terms of the idea that it really is just all about this energy, the heat, and how it migrates and passes between things. And just so whatever. Just no hope. This is the truth. Frankly, this is just it's so bizarre and it's so abstract and it's so caught up in. You talk about lost in math. I mean, it's not even coherent math. I mean, it's just a bunch of symbols representing some obtuse theory regarding the existence of some dimensional something or other doing some kind of bending of something or other in some method that we're not even allowed to know. And the fact is, we already know that I could sit on the space station and I could throw a rock and I can make it hit the moon. I mean, come on, it's just not all this. I don't need to do all this crap, to figure out that the idea is pretty simple. It's just motion, and the fact is there are forces that are going to oblige the motion to happen in a certain way, and that's it. And it's not anywhere near complicated enough for all of this crap to have any part in it. Alright, so anyway, I gave it a shot, and yes, it was a waste of time. But whatever. I figured it was obtuse because he never could explain it. I mean, he's been on talk shows talking about he's got this theory, blah, blah, blah. And yeah, this is what it is. It's obtuse. More, in my opinion, looks more complicated than the standard model. So what use is it? Frankly. So if he thinks he's going to fly off of the Earth, right, he's going to solve some kind of gravity problem. He's doing that interstellar thing. Somehow we have to leave the planet. This ain't going to get you there.